In this example that we're going to write together, we're going to highlight the differences between a class variable and an instance variable. We have started writing a customer class, as you see on your screens. We're going to insert very few lines of code inside. Let's, for example, say that we want to keep track of the name of every customer that we create. How are we going to do that? We can have a variable, an instance variable, where we keep the value for the name of a customer. It makes sense to declare it as a string and give it that particular name. Now let's go and start creating customer objects. Let's go and write a program. What does it mean to write a program? Write a main method inside a class. I could go and just insert the main inside the customer class. I will do it differently so that you become maybe more familiar with the fact that we can have several classes interacting. So we're going to create a different class named customer program, where we're going to, let me just split this so that we can see them side by side. So inside the customer program class, we will have the main method. Let me write that so that we go and start creating objects. You probably are familiar by now quite a bit with how we write main. Great. So let's create our first customer object. How do we create an object? We use the new operator, and after that the name of the class. We will see that actually this is called a constructor, but let's leave that for later. With a pair of parentheses, the name of the class with a pair of parentheses, if we don't have a different constructor inside the customer class. Again, if this is a forward reference. So here is the statement that creates a customer object. Now we want to be able to refer to this particular object later. How can we do that? We need to assign this object to a variable, and I will call it Alice. And since this variable is holding a customer object, the value of that variable is a customer object, we're going to declare that the type of that variable is also customer, same type as with the object. In more advanced topics, we will see that the reference and the customer do not have to have exactly the same class type, but this is definitely a more advanced topic that we will see later. For the moment, the reference variable and the object need to have exactly the same type, exactly the same class to create them. So we will go and create one more object and assign it to a different variable, say Bob. So remember, statement lines 8, lines 9, each of them does three things. I create the customer object, I declare a reference variable of type customer, and then I assign that object, that value, to my reference variable. If you don't remember very well what references mean, what is the difference with primitive types, go back to those lectures that highlight the differences between primitive types and reference types. In particular, take a look again at those simplistic diagrams that we had made on how the memory looks like when we create a primitive type and when we create a reference. Great, so each of those objects, each of those customer objects now has a name, and we're going to give a value to that name variable. How do we do it? Always through the reference variable. So for the object referenced by Alice, we're going to use the Alice reference variable and give it the surprising, probably, name Alice. And we're going to do the same thing with Bob. And so we have given a different value for each of the two name variables. And if you don't believe me, or in any case, it is always good to check, let's print the names on a single line per object. Let's print the names of the Bob object and of the Alice object. Now you will see that I will go and I will run this program. I will select the run option through the menu. Depending on your machine, it is very highly recommended that you actually learn the shortcuts for compile, for run, for any kind of operations that you do often, because it definitely speeds up the time. I don't want to be using shortcuts here and you not see what I actually do. I compile or I run. That's why I select the menu and then the options. But for you, on an everyday basis, do learn the shortcuts for your particular system. So we have the Alice name printed and then the Bob name printed as expected. The important thing to keep in mind is that each of the customer objects has a different value, its own value for the name field. It could be that although this object, the second customer object that we created, is referenced by a variable called Bob, we could have given exactly the same value. It does not mean that we have one name variable that has a particular value. There are two name variables, it just happens that they both have the same value. Let me leave it as it is. Let's now go and see something different. We're going to include one more variable, one more field in the customer class, which is a little bit different, not only because the type is different, this time it is an integer, but also because it is a static variable. It is a class variable. What does it mean? It means that all objects share this variable. There is a single count variable, no matter how many customer objects we create. And for this reason, the value for this variable will be shared among all of the objects. How are we going to see that? Well, let's give a value to count through Alice and then change it through Bob and see what is the final value. And notice that I am printing the count variable through the Alice reference object, right? So when I provide a value to the count variable through Alice, I give 1. However, when I print, again I do it through Alice, but in between we have changed the count variable through the Bob object. So let's see what will be printed this time and any surprises that may happen. So again we have the two names, Alice and Bob, and then we have 2 printed on the screen, which is not the value that we assigned through Alice, it's the value we assigned through Bob. And this is just to show that the value of that variable is shared, because the variable itself is shared. The Alice customer and the Bob customer objects share this count variable. There is a single count variable no matter how many customer objects we create. One more thing, and you may notice here that IntelliJ is giving us a short comment which says that the static member customer.count is accessed on line 17 through an instance reference. What does it mean? The count variable is declared as static. It is a static variable, which again means that all of the objects will have exactly one variable that is named count. It is also called a class variable. And because of that, we can actually access it through the class name. We can say customer.count. Not only that, even before we create any kind of object any kind of customer object, we can go and give a value to the count variable. It exists even if no customer objects exist. We will not have any kind of compile message error happen because we are accessing a variable before we create any customer objects. This is the power of static variables, but they need to be used only when they are really needed. And when is that? Usually when there is some kind of information sharing among customer objects, information passing among customer objects. For example, in this particular case, the count variable, we might be updating count every time we create a new customer object, just so that we know how many customers do we have. Every time we create a new customer, for example, we could be updating, increasing count by 1.